Hello, so we are back. Okay, but this time we have an interesting job, and I start this video for a reason. Yeah? We're usually not doing like videos from simple jobs, but this looks interesting. And what this is doing, this is a liquid damage job. Yeah, this laptop came here with water damage 1 to 0. Okay, good. Keep in mind, this is a very risky job, so you can have a surprise to fix the motherboard and actually find out the keyboard is not working out. And this keyboard is it's not that easy to be replaced. Okay, good. Now the charger is plugged in and we have the light. We can believe that. Pressing the power button, nothing happened. Oh, actually, it is coming on. It's coming on and goes off. Why is coming on? 1 second, let me check because I start this video from a different reason. You can't see the screen. Okay, let me use the other multimeter. On this one, the power button was dead. Actually, I was pressing the power and nothing happened. So we have on the screen, you can see on the screen the meter on the screen 3.3, pressing the power button. And look, the voltage is going down to 1.1, staying there, and the laptop stopped. Okay, so that's the issue. Power on. Look at the voltage, like 1 volt. And now power off. When it's powering off, the fan goes off also. Okay, first let's disconnect the power button. Okay, because that's the easy way to check. And now we have 3.3 shorting to ground. The laptop is coming on. But look at the voltage. Check the voltage. That's not supposed to be there. Okay, and the laptop turns off. So the power button is not supposed to work like that. This pin from here is coming from our EC controller, the CEO chip, startup chip. Okay, and has a pull up resistor to 3.3. So as soon as I turn it on, let me short the pins because it's easier. Short, I release the short and I should have 3.3, not 0.9. Okay. And when the laptop turns off, actually I have 3.3. You see, I can bet there are a lot of laptops like with this fault, comes on, goes off. So it's good to check. Always with a multimeter on the power button connector. Okay, looks like the power button is working now. Yeah, that was, I was believing, actually the power button is the issue why the voltage is not coming straight away back to 3.3 when I'm releasing the button. I was thinking, it's the button, but it's not the button, it's the board. The board indeed has liquid damage. Let's try and fix it. And yeah, there's no picture on the screen, even if I... Let's try and fix it. Let's try and fix it. Let me take the board out quickly. Indeed, it is liquid damage. But let's try to fix this together. But it's an interesting fault. I mean, I'm releasing the button, but the voltage doesn't come straight away back to 3.3. But it is coming when the left turns off. Strange. And yeah, we can see the liquid comes here. We can see some liquid damage on the board here. And a disconnector. Oh, that's bad. Okay, check here. Hopefully the pins are fine. The pins are fine. Now it's weird to work with this microscope after I get used from the one from. Okay, that was easy. That was easy. Now the hard part is to clean this. So check here. I don't know how can I do it to see. So check here what is here. It does the liquid damage. Yeah? Yeah? Give me 1 second, yeah? Okay. Uh, we just booked it on TV. Good. How we are cleaning something like that? I mean, how we are cleaning this kind of damage? And you know what? This I learned it from you guys. Yeah. With water. Yeah, because the sweets, the sugar, it will get dissolved in water. This is most likely sugar. If you drop something on the laptop, very clearly, most likely it will have sugar. So let me grab water. Yeah? No, I need to clean the board. Okay, let's do it quickly. So the way how you clean a liquid damage is with water. Oh, come on, dodgy water bottle. A lot of water. That's how you clean sugar. And you know what? Before you tell me, guys, about this, I was just trying with alcohol and it was not really working. And hot air, and it was not really working. But with water, check here. It's like new. Let's dry it. You know, I miss this hot air machine. Okay, let's dry it and check again. I mean, look at the board. It's nearly like new. You can see. The only problem is on the connector. We still have some. I can still spot something here. I mean, many times you can be lucky, like you fix, you just clean a water damage board and it start working. I mean, it's not necessary to be something burned on the board. Let me try my. Just be sure there's no water there before you are testing it. So what we have left is to clean that connector. Now I can bet the keyboard has to be replaced. I can bet that. Let's clean the connector same with water. Proper dirty. Now let's see, let's plug back the connector. But has to be on the other side. You think the keyboard is still working? Probably not. We'll see. Okay, here is some water. I don't want water on the board. The screen, the charging port. The keyboard, that's like a keyboard. The touchpad. What do we have to plug more? The fan. The power button. And the charger. Let's see. Did we fix it? Power button, the fan is spinning, you can't see it. The board is staying on. The board is staying on. And you have picture on the screen. You see? Now let's check again the power button. So the power button, so check on the screen. We have 3 volts, pressing the power button, going to 0, and it's coming back straight away to 3.2 volts, right? This is still dodgy. Let me take out the power button, check again. 2.4. It's going by itself to 0. Now it's 2.4. I'm not touching anything. 2 volts. I should have 3.3, not 2 volts. Okay, this is dodgy. So what we can do? We don't have schematic. We are taking the beeping multimeter and we are following the track, yeah? Beep, beep, I don't know if you can hear it. So the first pin is the pin, the hot pin, yeah, which is going to Super I/O. And it's coming on the other side of the board. Okay. We really have to follow this track to see what it's doing. The screen, we don't need the screen. We need a cable to be plugged in, yeah? We need a cable to be plugged in. Good. So this one is coming here, somewhere in, yeah. Here is okay, it's beeping. Here is okay, it's beeping, and I have 0 ohms. Ah, you can't see, okay. Here is beeping, I have 0 ohms. Hopefully it's not ground. No, it's not ground. Okay, so here I have 0 ohms. And this track should goes to the Super IO, straight to the Super IO. Yeah, it's going here, exactly here. I don't know if you can hear the beeping. So let me see. Okay, it's coming to this one, to this component. Let's have a look together to understand what is wrong here, because we have to fix it. We can't leave it like that. Okay, so the power button is coming exactly here, here. And it's going to the Super IO on this pin. So this is the pull-up resistor, okay? So on this side I should have 3.3, right? Okay, let's plug the charging port. Give me 1 second. And see what's going on. Let's plug the charging port. Remember, the Super IO has always 3.3 volts on it. I'll plug the charger now. I plug the charger. I'll get the on-screen multimeter. On-screen multimeter. And here, I do have 3.2. And here, I have 3.3. So this is the pull-up resistor, okay? Now let me short this thingy. And I have like 2.7, 2.8. But here I have 3.3. Here I have 1.4 right now. You can see on the screen 1.4, 1.3, 1.2. So what does it mean? Does it mean my resistor is dead? Now I have 2.2, you can see. 2 volts, 2.2. It is supposed to be 3.3 always. You can see on the screen 3.1 right now. 3.2. So this resistor is burned because that will be the first idea. The resistor is burned or partial burn. And yeah, you are wrong. Okay. Actually, what do you have? You have a load somewhere. You have like a random load on this track. And I don't know how to prove this. I can easily fix this fault just replacing that resistor with a lower resistor. That's the dodgy way. So which is the right way? If that's the dodgy way, which is the right way? You know, very possible. But here is clean. I can see it's. So my truck somehow is connected to somewhere to the ground. Like it's not connected. It's a resistance. It's a few kiloohms resistance. How you can find a few kiloohms resistance somewhere from the hot wire from the Super IO to the ground? Nearly impossible. How you will do it? Just be honest and tell me how you'll do it. Hmm? The track looks very, very good. One more time. Oh, no, here. Yeah, yeah. 3.2, yeah? Let's try something, yeah? A nice 3.2. Let's short this 3.2 to ground here, yeah? From here to ground, you can see. 3.2 short to ground. Going to 0. Then it's coming back to 2.8, 2.9. The board is dodgy, not the ribbon cable, not the power button. 1.4. Check on the screen. 1.4, 1.3, 2.3. You see those random numbers. Even going to 0. 1.2. But the input of the resistor is 3.3. So do we have a dodgy resistor here? Because I start believing actually we don't have like a virtual resistance to the ground. But actually we have like a dodgy resistor. Change the scene 1 sec. So what we should do, we should replace that resistor. Do we know what resistor is? Do we care what resistor is? That's the question. Do we care what resistor is? No. Of course not. Let me grab some flux. Why we should care? I mean, it's 3.3. How much the resistor can be? Like 2 kiloohms, 4 kiloohms, something like that. Right? Okay, so we have the hot air microscope. For what? For the TV? Okay, that's fine. Let's remove that resistor. Okay, so we remove the resistor. Let's try and check the resistor. We should check the value. No, no, we are tryharders. No. We don't care about the resistor. We like to experiment. We don't like schematics and things like that because there's nothing to learn. You'll get brain damage from the schematic using a schematic, and soon you will not have a schematic. You will believe you cannot fix it. Okay, so we remove the resistor. Let's get another board. Okay, so that's another board, random board. Let's get a multimeter, 20 kiloohms range. Let's find a resistor. I can't see any. They are too small. Okay, so let's pick up one. This one looks good. I mean, it looks fine. 12.5 kiloohms. No, it's too big. This one, 14 kiloohms. You can't see on the screen. Let me grab the other multimeter. Never use this multimeter on ohms. Okay, let's try another one. What about this? 22 kilo ohms. No, that's not good. What about this? This one, 11 kilo ohms. No. This one, like 1 kilo ohm. What do you think about 1 kilo ohm? Should be fine, right? Well, yeah, it's fine. 1 kilo ohm. Yeah, it's okay. What can happen? Okay, so we took the resistor out. And now we have to solder the resistor back here. Yeah, it's like new, like original. Now let's check the resistor one more time with the multimeter. I check on the screen, and he has 1 kilo ohm. Okay, 1 kilo ohm resistor. That's fantastic. Job done. We should test it. No. No, we know what we are doing. We are not testing. We know it's done. You have to trust yourself, right? We know what we are doing here. We done these dodgy things before. We are plugging the old connectors because we know it's working. Fan. We should even put the screws back, but we don't know if the keyboard is working. Yeah, we should check the keyboard. First, let's check what we done. Yeah. Now you'll think, sorry, maybe indeed was a resistance to ground. I know. I took that on consideration. But just because we use a lower ohms resistor, we should overcome that resistance to ground. Okay? So it's like win-win situation. Obviously, I knew, I know. Indeed, can be somewhere a resistance to ground. So let's plug the charger. We plug the charger. Let's get a multimeter. I plug in the power button. Okay. Now on the power button we have switch to volts. 3.1. Pressing the power button goes to 0 and come back to 3.1, which is fantastic. But the laptop is not starting. Okay, that's bad. Let's keep press the power button and you have 1.6. It's coming back with 2.7. Wow. Okay, let's short this to ground. Should work, Now the power button is dodgy. So short to ground and the laptop is starting. And the voltage is coming back to 0.5, 0.6. Why we didn't test it? You know, at this point, I'm thinking, I believe we can have a faulty Super IO. Because we replaced the resistor is doing exactly the same like before. Oh, that's bad. That's bad. Okay. Let me unplug this cable. So one more time, what we are testing. We are plugging the charger, getting the multimeter, on-screen multimeter. What is this light? Laptop is on? Oh. Okay. So what voltage do we have on this resistor? We have 1.5, 1.6 volts. The other side we have 3.3, 1.5 volts. We have 1.5. So here are two what can, on the other side of the resistor here we have 3.3. What can be here? A faulty Super IO. So this pin actually has an issue on the inside of the startup chip, or a capacitor on this line. It must be a capacitor, right, to overcome the switching from the power button. Yeah, let's check. Let's see. I think we have a capacitor here around the Super IO. Or not. Let me get my beeping multimeter. My beeping multimeter. So the here. And from here, oh, where is going? Okay, so if it's a shorted capacitor, where can be? Where is the high probability to be? Where was the water damage? You're right. Where was the water damage? Here somewhere. Can be a dodgy capacitor here. Let me see where the track is coming. Yeah, on what pin? So the track is coming here, here, here. No, only on this one. I can't see any capacitor. I can't see any capacitor. You know what we should check? I think the capacitor probably is on the power button. You know what we should check? The resistance to ground. Okay? We can come with the heat and find exactly where is the problem. So let's go on ohms. Ground. Now this resistor. So we have like 3.8 kilo ohms. Right? Now if we are coming with heat, if we're coming with the heat on Super IO, it's kind of changing. 3.8, 3.9. What about here? Oh, look now. 28 kilo ohms, you can see? So I just came with the heat on that connector. $32 kilo ohms, one more time. Okay, the problem is with the connector. The problem is with the connector. 35. 36 is going up. Maybe we left some water on the connector. Or is something on the back of the connector? I can't see anything dodgy here. The connector looks good. I can see something there on the back, but I don't know what it is. There, what's that? Hmm? Can clean it, right? You think will be the water? What do you think? Your opinion, you think? Because we can try. We can try to see if it's the water. So that's ground. That's my resistor. And we have 39 kilo ohms. Let's come with some water. Yeah. We have 20 kilo ohms. 17. With the water, yeah. Maybe we didn't dry properly the board. Now let's dry. $34, $45, $37. Looks okay. What do you think? $39. I mean, I believe that was the problem. I believe that was the problem. Again, I will leave this here because probably the keyboard has to be replaced. Let's test one more time, just to be sure. So you see, like a simple fault can give you a lot of work. I mean, this job was supposed to be done 5 minutes. Let's plug the keyboard. Charging port. Okay. And let's plug the fan. Okay. Pressing the power button. And the laptop is not coming on. Let's check the power button. Volts. The voltage is 3.4, which is fine. Pressing the power button is going to 1.6. No, it's fine. So check here. Pressing the power button is going down to 1.6. That's because we replaced the resistor with a resistor which is not supposed to be 1 kilo ohm. So it's like divider. Yes, somewhere in the serial mode with the power button, we have another resistor, but it's working fine. Yeah? Now we have stable voltage. If we are shorting here, the trucks, the fan is spinning and the laptop is coming on. You can see. But we just give us ourselves some work because we replaced that resistor. And I didn't think it's another resistor in the serial mode with the power button. So now we are going to modify the manufacturer schematic. Let's find out the resistor. Let's find out the resistor. So from here, the truck is coming. Here. Okay, so the truck is coming here. And from here, that's the resistor. You see? You see this one? This is the resistor. This resistor is... I can't see. Anyway, that's the problem now. We have to remove that resistor. What will happen? The current probably will goes a little bit up on the power button, but the power button is fine. It can handle more current than that. We are speaking about microamps, milliamps, probably milliamps, microamps. I don't know. But it's a good practice, and I will use Rosin. I'll use Rosin 1 second. Let me put some Rosin there. It's a good practice, you know. It's a good practice to believe in you and to understand the manufacturer is a guy like you. Doesn't mean if he fitted this resistor here, it should be here because that's the manufacturer said. No, we can take his schematic and modify it. But this is electronics, yeah? It's not Apple, where we cannot replace the battery because they fit a chip with a serial number on it. By the way, you know why I have a Samsung phone? I have a Samsung phone from about 3-4 days. And I'll never come back to Apple. Never. Because Diana made a video. Yeah, Diana started uploading videos. Okay? And she made a video because the phone was saying battery health 100% on a 3 years old phone, iPhone 11 Pro. And I said, okay, just do your video, prove the point actually is lying. The battery health is lying, and she did it. She tested the battery with the tester, with the capacity tester, and she proved the point. Actually, the battery was like 2,300 milliamps only. But anyway, I said, you know what? If you open the phone already and you did your video, I will replace the board. I will replace the battery. I will take the board, the original BMS board. I will move it on a new battery, and I did it. As soon as I took out the board goes dead. I mean, was not outputting any current, was not taking any current. So basically, I broke Diana's phone, and now she had on the phone a battery which has that message which is not genuine. So I get mad, I get pissed off, and I said, okay, from this point, no Apple on our house, yeah. So I bought 2 Samsung phones for me and Diana, and that's all. Me with Apple, it's end of story. Okay, we plug the charger, pressing the power button, and the laptop is coming on. Okay, so now if we are checking, see, this is a very ugly company. Always, we are so environmentally friendly, but you cannot repair their devices. Yeah, basically, it's a lie. The whole things with recycling is just a big lie. Okay, so let's check. Let's check together. So we have 3.3 on the power button. Pressing the power button and the voltage go exactly to 0. You can see. Releasing the power button, the voltage come back to 3.3. Okay. So this laptop is fixed. We can see the screen. I have to plug the hard drive, obviously. The keyboard. The keyboard is still working. Press F2. No, the F1, F2. Oh, the keyboard is still working. Unbelievable. Maybe there are some keys which are not working, but this has to be tested. Anyway, I'll stop now. Thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.